Hello and good evening to you all. We are Daniel and
I'm Steven.
we are working on a project that measures the heart pulse of a human using simple electronic circuits. First of all, simple electronic circuits includes resistors, capacitors, diodes, transistors, and all that. And why do we want to do this? We want to optimize the cost of buying expensive and overrated appliances for doing basic things like checking your heart pulse, like reading the temperature of the surrounding, and all that. So basically, the project uses the transmission and then receiving of an IR signal, which would be transmitted through your thumb when you place it on our sensor. So depending on the state of the vein, whether it is closed or open due to the flowing of the blood, then we can receive that signal and then filter it through some active and passive filtering systems. Then you can be able to amplify it to blink this LED you are seeing here. So literally we used a passive filter here, which is a high pass filter, because we want to filter out the DC noises to pick up the heart pulse, which is an AC signal. Using that, we have to magnify that small heart pulse using this first op-amp here, which is an active filter that has a magnification of 101, and that's active filtering. In other words, it also does further filtering of the AC signal that we have in to give us that particular heart pulse. Now we need to magnify that small heart pulse we've got here into a bigger one to be able to turn on our LED. So this op-amp again has the same magnification as the one before, and it does the another active filtering and then amplification. Now the final process is for that voltage or that input signal to come and use to power our LEDs, where in the form of which your impulse or your pulse is moving. Your pulse is moving, yeah. So we would like to demo it for you to see. So as you can see, this is a demo of someone using the heart pulse measuring instrument, and you can see from the oscilloscope the heart pulse being graphed. It's stabilizing, so it's a little bit good. So this is the person's heart pulse. This is Steven's heart pulse at the moment, and this is all Steven is doing. His hand is on the IR sensor, as you can see, and the LED there is blinking to show you how the blood is moving through his hands and his vein. So you're going to measure the beats per minute by getting a stabilized frequency from our oscilloscope.
The light interfere with the frequency, so you know the correct frequency. So as you can see, the beats, the frequency is around 1.2938. That's where it gets stabilized. So we are going to use the 1.2938 and multiply it by 60 beats per minute, because 1 hertz, 1 beat per minute is 1 hertz gives us 60 beats per minute. So to get the beats per minute, you have to multiply it by 60. So we are going to use the 1 point. I think now it's because of the light is changing the frequency, because light too is an IR. So the beat is around 1.2939 hertz. So we are going to use 1.2954. So 1.2954 times 60 is 77.724. So to confirm, we are going to use an iWatch which can measure the heartbeats. So measuring the heartbeats. So 1 minute ago, so it's measuring. So looking at it, you are getting heartbeats of 78 beats per minute, and over here we are at 27.24. So you can see they are very close to each other. So to conclude, basically this circuit records the heart pulses of a human being, and it was an amazing project because we had to go beyond what we learned in class to learn about active filters, which helped us to do the filtering whilst amplifying the signal of the heart pulse. Yeah, so thank you for listening to us.